Hello YouTube, my name's Andy and I have completely ruined this white t-shirt in the washing machine. I often think to myself, what's the worst that could happen? And, well, it's not the end of the world. In the case of designing guitar pedals, as I'm swapping these components about on this breadboard, I think to myself, what's the worst that could happen? And in that circumstance, I do tend to on the side of caution. I don't want it to explode. So here's the first test. I've swapped out the input resistor, the 10k input resistor, for a 100k resistor. It still works. Now I'm going to swap it for a 220 ohm resistor. Oops, probably should turn the power off. Power off while I'm doing that. There we go, 220. Still works. I've redrawn and slightly simplified this diagram. The resistor we're talking about is that one. It doesn't seem to make much difference whether it's 220 ohms or 100,000 ohms. The distortion circuit still works as a distortion circuit. Now the absolute maximum current that this transistor says it can cope with is 600 milliamps, which doesn't sound like very much at all. Milliamps doesn't, you know, it's a small number. However, it is quite a lot. 9 volts is coming through that resistor and through the transistor down here. And in order to make sure that that current does not exceed 600 milliamps, this has got to be at least 14 ohms. I swapped out the 100k resistor that's connected to the collector of the transistor for a 220. 220 is comfortably more than the 14 ohms necessary to limit the current through. And I got no signal. And I thought I'd wrecked the transistor. So I've swapped it back to the 100k resistor and it does appear that the transistor is working fine. So what's really happening is that this transistor has been turned into an on-off switch. I think it's probably slightly more complicated than that, but when the input signal coming in from the guitar is positive, then there's no current flowing through here. That becomes 0, and the voltage here becomes 9 volts. But when the signal goes negative, and it's on a sine wave thing, then provided that can overcome the voltage that you're getting from through the big resistor there, then that will switch the transistor on and we'll get 0 volts here, because effectively all of the voltage will be dropped across that resistor. Now that sort of on-off situation is like a square wave, and we know what they sound like. This is a 10 nanofarad capacitor. That's quite big. It's supposed to be 15 nanofarads, but I haven't got one of those. I've got quite a few to choose from though, so we've got one of those in there. What happens if I change it for a 47 or a 4.7 nanofarad capacitor? Still works. And I'm thinking that it seems to have lost some of the low end. If there is a difference between 4.7 nanofarads and 47 nanofarads, it's quite small. In order to be able to tell what's going on, I think I'm going to need to make some bigger changes. So the final test for this episode is going to be 1 nanofarad followed by 100 nanofarads, and 100 is the biggest I've got in that little box. That's all I'm going to do for today, but what I've learned is that I can mess about with this input resistance quite a lot, and it makes almost no difference to the sound which comes out. If I mess about with that resistance, I can successfully make the whole thing not work. If I change this capacitor, it affects the amount of bottom end that we get in the circuit. Now, I like that 100 nanofarad sound, so I'm leaving that in for next time. Meantime, thank you very much for watching, and I'll catch you next time. Bye.